Hello, welcome back. Here in our next section of chapter 1, we're going to go through a whirlwind journey of a whole bunch of people in history that worked to prevent disease. So again, we've gone through spontaneous generation, fermentation, what causes disease, and now we know there's a connection between pathogens, microscopic pathogens, and disease. Now everybody's like, well, how can we stop people getting sick? Now that we know what causes it, it's not just some weird random kind of magic that makes you sick, but there's an actual thing that we can fight against. So we're going to go through these little mini stories, and again, some of them are in this book if you want to read about Semmelweis and Lister and Jenner and stuff. So, all right, so our first cast of characters here is a doctor by the name of Ignasi Semmelweis. It was about mid-1800s, so a little bit before Pasteur's time, so and a little bit before Koch. So we didn't really know too much about bacteria and germs at this point of his story. So here's how the story goes. He was a doctor that worked in a medical ward that a lot of times had a maternity ward. So women were going there to have their babies, but there were still a lot of women that were having babies at home because that was kind of what they did. It was kind of a new thing for the ritzy, fancy women to go to the hospital and have their babies there. And then there's also another ward in the same hospital, different wing, that was run by midwives. So you had women giving birth in the hospital with midwives. You had women giving birth at home with midwives or family members. And then you had women giving birth in this particular place that Semmelweis worked in. And he was making, again, observations. He was making these observations that there was quite a few women in his ward that were dying of what was called puerperal fever, which is childbed fever, is sometimes what it's called. He saw almost 20%, 1 in 5 women were dying from this infection after they gave birth. And then he was hearing from the other ward that just had midwives or women who were giving birth at home that hardly any of their mothers were dying from childbed fever. So he's like, that's really weird. I don't know what's going on. So the story goes that the obstetrics ward that he was working on was very close to the medical school's cadaver lab that the med students were practicing their anatomy. They would go in and do their anatomy lesson on the cadaver, and then they would come in and assist the women with their deliveries. And that was the connection that was physically there in that space. One day, the story goes that one of his colleagues accidentally cut himself, whether it was on his finger, or I think in micropunters it says his knee or whatever. He somehow, with one of the tools of the dissection cadaver lab, he broke his skin, cut himself. A few days later, he died of the same disease that the women were dying from. He's like, that's not a coincidence. There's something going on. So maybe there's something that's in the cadaver lab. Again, we don't know germs yet. This is pre-Koch. So maybe there's something weird, cadaver particles is what he called them, that these medical students are bringing into the obstetrics ward, and that's what's causing these women to get sick, because his friend died of the same thing, and he wasn't a woman. He didn't just have a baby. So he introduced this idea of everybody coming from the cadaver lab, wash your hands in chlorinated water, and then go and assist in the deliveries. Something as simple as washing hands. People didn't do that back then. So the statistics that he came up with, from a 1 in 5, so around a 20% mortality rate of women with this childbed fever, in 1 year dropped down to less than 2%. So 1.3% drop down to 1.3% mortality in that 1 year. You think everybody would want to wash their hands, right? This is amazing data. But alas, that was not the case. He was ridiculed for his ideas because imagine if you were a doctor, that was a pretty prominent position in society, to be told that you were the cause of why your patients were dying. So he was not widely accepted, and this was in Vienna, I think. Ridiculed in Vienna. He went to Hungary and was accepted in Hungary. But he also had some weird political leanings that kind of made him an outcast in society. And ironically enough, again, the twist of this story is that he ended up in a mental institution because he kind of went a little bit cuckoo, and he died of the same thing, this streptococcus infection puerperal fever. How's that for irony, right? So he invented washing your hands to prevent the spread of disease. He is now in all the microbiology books as this herald of personal hygiene, which is kind of a great story. Okay, on to our next contender here. So this is a guy named Joseph Lister. So that last name might sound familiar. You might have a product in your bathroom that is related to his discovery, if you will. He is the father of what we call antiseptic surgery, and you may have some Listerine, is that antiseptic mouthwash. So Lister, this was, again, the late 1800s, mid to late 1800s. So he was a surgeon, and back then, if you needed surgery, you had about a 50-50 chance of surviving the surgery, not only just from a bad surgery, but by infection. So you had about a 50% chance of dying from infection. So it wasn't always the safest route. And so surgery was usually the option of last resort. You're going to die anyways, so you might as well try it. So he started spritzing, and you can kind of see in this drawing, this little spray bottle. I'm showing you in my hands, but you can't see what I'm pointing to. So this little spray bottle right here is spraying this, I gotta look at what it's called, carbolic acid or phenol, a couple names for the same thing. He would kind of mist this phenol over the surgical table, and so it just kind of mist over the surface. And then he saw a great reduction by about 2/3, so that's like 66% in infections post-surgery after he was spritzing this phenolic acid over the open body parts. And it's a very good antiseptic. It's actually pretty dangerous to human tissues, so he probably had it diluted to some degree, but we don't really want to mess around with phenol. And if you'll notice in this particular picture, it looks pretty aggressive in this surgery. It doesn't look like it's much different than like a kitchen table. And they're wearing suits, no masks, no gloves. They didn't have any of that back then. But what is this guy doing? Who is this? Who do you think that character is and all the people around the table? It looks like he's suffocating that guy or holding his chin up. He would be the anesthesiologist. So they knew about certain anesthesias like, oh, I can't think of it, chloroform. So he'd probably have a bottle of chloroform, put it in a pad, put it over the person's face, their mouth and nose, have them breathe in, and that would keep them unconscious while they did the surgery. And he'd have to keep reapplying that because chloroform isn't a long-lasting anesthesia. So he had to maintain, put little drops on there or whatever. So it's kind of an interesting picture of Joseph Lister and his antiseptic surgery, reducing the rates of infection because, again, they don't know cleanliness. Their tools are probably not very clean. Their hands are probably not very clean. If they didn't clean the wound or the surface of the skin before they cut into it, you're introducing all of those pathogens into the body. But if you spritz it with some of this antiseptic, you're killing those invading bacteria and you're going to reduce the risk of infection. All right, our next character is Florence Nightingale. If you are on the track to a nursing program, you're probably going to be learning all about her if you haven't learned about her yet. So Florence Nightingale was, and again, mid to late 1800s was her kind of tenure. In the mid 1800s, 1854 to 1856, there was a war going on. She went and helped kind of introduce hygienic practices to these military hospitals. They saw a lot of death of the soldiers, not just from the wounds that they received on the battlefield, but infection post-treatment. And so she saved many lives by cleaning the wards, changing the bandages, taking out the dirty laundry, providing clean dressings for wounds. And then when she came back, she founded the first school of nurses in England, I want to say. And so she is kind of the namesake for most nurses as far as the profession goes. So Florence Nightingale is kind of has her place in history for that. Our next individual is a guy named Jon Snow, and I did not watch Game of Thrones, but apparently that's the name of a character in Game of Thrones. That's about all I know because people have told me that. So Jon Snow is connected to a field of science called epidemiology. You might be hearing a lot about that now with the coronavirus and things going on in our world right now. Now, let's see, Snow, again, early to mid 1800s. We're still kind of smack dab in the middle of the 1800s. So there was a disease called cholera. Cholera gives you really bad diarrhea. It's like watery diarrhea, and you can die of dehydration in just a matter of days because your body is losing so much water, you cannot replenish it enough, your electrolytes go out of whack, and you die. And there'd be some cholera breakouts every once in a while, outbreaks every once in a while, kind of periodically throughout the world and throughout London in this particular case. So in a pretty nasty one, particularly nasty outbreak, what he did, he actually went to the neighborhood and he knocked on the doors. And I have a map on the next slide, but I can't backtrack in this recording device. So I want to point out these pictures first, and then I'll go to the map. He went out and he knocked on the doors of all the people in this particular neighborhood where there's lots of cases, and he just kept track of the cases of cholera. And then he had on this map, and he isolated a single particular pump, a water pump that people were getting their water from. And this is the picture of it right here. It's the water pump at Broad and Cambridge Streets, and they still have it kind of memorialized there in modern day London. And so he took the handle off of that pump. He got the health department to agree to that. And then once he did that, nobody could get water out of that particular pump anymore. And the cases of cholera went down. So let's take a look at that map that he made. So here's a map of all the streets of London. So here's Broad Street is right here. And here's Cambridge Street right here. And here's the pump that we just saw in that picture. And each one of the little black lines represents a case of cholera in that neighborhood. And if you'll notice, there's a lot of cases like right here, right around that particular pump. And if you'll notice, there's other pumps here, here, where's some more pumps? There's one right here. And in these other pumps, there weren't as many cases of cholera. So he's like, well, it's not in that water. Maybe it's in the water that they're getting from that particular pump. Because you'd ask them questions. Where did you get your water from? Oh, I got it from the pump at Broad and Cambridge Streets. So tracing the diseases helped to identify the source of where that disease came from and try to limit the spread. And that's exactly what's happening in our country right now, is we are needing to find where these cases are coming from, limit the spread of those cases, and so the disease does not go crazy in our population. So, staying home when you're sick, this idea of contact tracing. So if you do show up, they can say, who did you talk to? Where did you go? And then they go and communicate with all of those people and say, you've been exposed, stay home, blah, 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 all that kind of stuff to help prevent the spread of disease. That's epidemiology, is a study of the spread of disease. Kind of cool stuff. We're living it right now. Okay, a couple more folks in this is a little bit longer of a video because we've got a lot of people to talk about. This next guy, his name was Edward Jenner, and he is known for kind of creating the vaccine, even though we didn't really call it a vaccine when he was working on it, and he didn't really know what he was doing. I know that's not a really nice thing to say. So here's the story behind this discovery. Is smallpox was a crazy bad disease, and you can see the picture of that guy's shoulder with all of these pox on it. It's eradicated now. It's the only disease that's ever been eradicated from the human population. I think the last case was in the 1970s. But before then, it was serious. A lot of people died of smallpox. There was a slightly similar disease called cowpox, but it wasn't as fatal. And it was often women who were the cow maids. They would milk the cows. A lot of times they did not get smallpox. And they noticed, he made an observation about these women, is that they had fair skin. Now, when you get a case of smallpox, it scars your skin, it scars your face, it scars your body. So even when the pox go away, you still have those scars. Well, the cow maids didn't. They had really fair skin. So his mind starts thinking, he's like, okay, so what's going on here? These women probably got cowpox, but they're never getting, I don't want to say never, but a lot of them are not getting smallpox. So maybe there's something protective in having cowpox that protects you from getting smallpox. So this experiment, and there's some controversy over who the child was, but there was a child involved, whether it was his own or somebody else's child. He purposefully infected the child with cowpox. The child got sick with cowpox. The child recovered from cowpox. Okay, no biggie because it's not a very deadly disease. It's not a deadly disease at all, just a mild infection. Then after the child recovered, he purposefully infected the child with smallpox. That's the ethics kicker in this story. Luckily, his observations were correct in that being sick with cowpox was a preventative measure, something in the body, he didn't know what it was. They didn't know anything about the immune system or T cells or B cells or antibodies or memory cells. None of that was part of his knowledge, but they knew about immunity. They knew that people who got sick with something didn't usually get it again. So he had some foundational knowledge to build upon, but just not the physiology and the mechanics of it at the cellular and molecular level. Anyways, the kid didn't get smallpox. And so this started this new round of science of immunology and vaccinations is let's study how our body naturally fights disease and can we manipulate that to prevent us from getting a disease. And so that's where vaccines are. Vaccines are you purposefully infect yourself, not infect, you purposefully present that particular pathogen in a safe way, not an actual disease, to build up your immune response. So when you do get exposed to the actual disease, you're not going to get sick because your immune system is ready to go to recognize it. Okay, last guy. So the last guy in our story here is Paul Ehrlich. Okay. Hopefully I'm still on. My computer kind of took a pause there for a second. So our last guy in the story is Paul Ehrlich, and he is known as the father of chemotherapy. Now, a lot of times when we see or hear the word chemotherapy, we think of cancer, which is not too far off because that's what it is. But on a broader sense of the term, chemotherapy is using chemicals to attack bad things while leaving healthy things alone. And things, I'm mainly talking about cells. So he came up with this idea of what's called selective toxicity, where if we get the right chemical, we can go in and target the bad thing that we're trying to get rid of and leave the healthy cells alone. Selective toxicity. He was working with syphilis, which is caused by a bacterium called Treponema pallidum, which I have the picture down here. That's the little critter, nice little spiral cell, causes syphilis. And so he went through a lot. Read about it in Microbe Hunters, his story. Hundreds of modifications of these chemicals to try to target just the syphilis bacterium while leaving the rest of the cells alone. Because, hey, you could poison everything and you'd kill the bacteria, but you'd kill the patient as well. So we want to avoid that as much as possible. So we want to kill the pathogen and leave the healthy cells alone. So in cancer chemotherapy, we're trying to kill the cancer cells and leave the healthy cells alone. So it's all connected in this bigger idea of chemotherapy. Okay. All right. So what a wonderful journey. So you have all of the notes of these people, right? All of these people in the lecture notes. You can fill it in. You can take a look in the textbook. So these are the stories of people who are working to prevent disease and infections. Okay. We have one more lesson to finish up chapter 1. That's going to be what's going on in the modern age of microbiology. I will see you then. Bye.